say I wanted to make a box out of a piece of paper. Well, this isn't really a piece of paper. It's a 3 by 5 note card. So this whole length is 3 inches, and this is 5 inches. And I want to make basically an open-faced box out of it. So to do that, I would need to cut out corners, 4 corners, and we'd like for those to be nice and square. So let's see. What if I chose a certain length? And I'm going to be kind of crazy and not even measure it. I'm just going to cut out a square. Now, whatever I cut out of that corner, I need to do it out of all 4 corners. So I'm going to lay it on top of that corner and cut there. This is going to be very strange. And I'm going to do the same thing out of the bottom one. Now you're saying to yourself, this does not make a box, Miss Nice-Horner. This is just weird. You like cutting things. Yeah, I did. I like playing with scissors and crayons and stuff in kindergarten. But it does make a box. If I fold up the sides, now that I've taken out those corners, I do actually get a box. Now, I didn't measure the size of that piece that I cut out, but how big of a square would I need to cut out of each corner to make this the most volume I could hold in my little box? Well, let's kind of go to paper for a second here. We started off with a 3 by 5 note card, right? And whatever I cut out of that corner, I'm going to cut out the same thing out of each corner. So when we think about this box that we made, it's got a width that used to be the whole 3, but now it's less, because the whole 3 would be all the way this way. Well, how much less is that width? Well, the width was 3, but then we cut out those 2 pieces so that they would fold up. Well, what if I made the length of the side of those squares x? Well, I took away one x this way and then another x this way. So my width would be 3, taking away both of those sides, so 3 minus 2x. What about the length? Well, if it was still the whole note card, it'd be 5, but we're taking away that length and that length on that side. So this is an x and this is an x. So our length would be 5 minus 2x. Now, what is the height of my new box? Well, let's see. Okay, right now it's nothing. When I fold up those sides, look what becomes the height. That piece right there, which was the side of that square that I cut out. So the height would just be x. So, now we're looking at the volume of this new box. Well, our volume is made up of length times width times height. So we've got our height was x, our width was 3 minus 2x, and our length was 5 minus 2x. We now have a function, and let's write it in function notation, for volume in terms of x, the length of the side that was cut out. Now, could we find, let's see, what are our possible values of x? Well, x can't be 0, right? We wouldn't have anything there. Well, x couldn't be bigger than 3, or else we wouldn't even cut out enough to have a box this way. Well, really, not even 3, because you could cut out to about here and stop. So x has to be between 0 and, what, 1.5? Because if I get all the way to 1.5, I'm cutting to here and then cutting to here. I'm just cutting the whole note card away. But could we find what x value gives us our maximum volume? Well, I like to use a calculator for this type of thing. So I'm going to go into my y equals, and I'm going to put in my equation. X times 3 minus 2x times 5 minus 2x. And let's look at the table and see what we see. Let's see, it goes all the way up to 1. But then when we got to 2, notice I said that we had to be between 0 and 1.5. Our volume is negative. So my window really needs to be between 0, well, 2 is fine. And what are our y values going to be like? What is the maximum volume for that? Well, I don't know. I know it can't be smaller than 0. And I don't think it's going to be bigger than 10. Let's see. Ooh, it's way less than 10. But we have part of one of those cubic functions, that curve. Our maximum value is actually occurring right there at the top of that hill. To let the calculator help us find that maximum value, we're going to go to the Calculate menu. And maximum is the 4th option. And we have to, they call it bounding. You're narrowing in where that maximum value is. And the first thing it asks us to do is to left bound it. So left bound means to take your little cursor to the left of where you think the maximum is and press enter. Right bound means to go to the right of where you think it is and press enter. Guess, I think it's about there. Let's see what it is. To maximize the volume of my little box, I need to cut out a square of 0.6 inches. Well, 0.607 would be even better. And what is the maximum volume that we get? That maximum volume would be 4.104. 4.104, this was inches cubed. And that's how you can maximize the volume of a box.